This is a rotated ellipse. We're going to find these points using implicit differentiation. This is 3.1. I already showed you guys this. This is for people at home. Let me switch back over to. There we go. Now we're all on the same page. It's essentially DDX on both sides. Okay. So the derivative of x squared is 2x. The derivative of xy, when we do xy, we're going to do ddx of x times y, and this is in minus because there's a minus sign up front, plus x times dx of y. That's this portion right here. So when I do that, I'm going to have derivative of x is 1, so I'm going to have minus y. And then I take the derivative of y, it's dy dx. I still have an x, and I still have a negative. That's going to be negative x dy dx. Then we do the y squared. Bring the power down, lower the power by 1, and then do the derivative of y, dy dx. And the right side equals 0.
So we have a basically just have negative y after the first dy dx at the top, and then we keep the x derivative of y. And it's just negative.
Yeah, well, this one, derivative of x is 1.
Because that's 1, yeah.
So that's the first term right here, the negative y. And this one is, x stays alone, the derivative of y is just dy dx.
Okay.
And then we got to hit both with the negative. Okay. All right, so I'm going to subtract everything over that does not, or add everything over that does not have a dy dx. And in the next line, I'm going to actually factor out the dy dx at the same time. And I hate having negative shit in front. So when I divide, I'm going to rearrange the shit I'm dividing so that the negative is afterwards. On the top, I'm going to make this top y minus 2x. And we're dividing by this. I'm going to make that 2y minus x. I just hate negatives up front. I don't know why. I think I'd be okay with it, but it just makes me fucking twitch. All right, so this is the slope of tangent lines. And let's find the horizontal tangent lines. To that ellipse. Horizontal lines have a slope of what? 0. So that means dy dx should equal 0. So we're going to have y minus 2x over 2y minus x equals 0. I'm going to note that 2y minus x cannot equal 0. So 2y cannot equal x. And if we see something later on with that, we're going to come call bullshit. After noting that, you can clear the fractions. If you clear the fractions, you get y minus 2x equals 0. So where we have a tangent line, y has to equal 2x, a horizontal tangent line. The way we're going to figure out where that is, we'll just take that and plug this into the original equation. So I had x squared minus x. I'm going to replace the y with 2x. Ray's got an easier job than this, I saw you folks. There's just not as many offices out here to fucking fix. And he doesn't have to go out there, he's just IT out here. It seems like a good gig to me.
What is that you have to plug? MIS?
This.
I'll plug this.
Eighth grade, that can't do the times table. Well, I don't know. I've seen college students that can't do the times table. It is not a big shock, but like if it's a lot of the period, that's bad. All right. So if I do this, I've got x squared minus 2x squared. This square is 4x squared. So clean that left side up, I get 3x squared equals 3. Divide by 3, I get x squared equals 1. Put the square roots of both sides, and what do I get? Plus or minus 1. And we're looking for coordinates, so we need the y value. We'll take these and plug these into y equals 2x. So when x equals 1, y equals 2 times 1 is 2. And when x equals -1, y equals -2. So we got the coordinates -1, -2.
So in this case, both points were that coordinate, so are both valid in this case, or only the negative?
Yeah, they're both valid. We actually saw neither of these break that rule. And we saw the ellipse was like that. So we did have 2 horizontal points.
Now I feel I think that.
You guys ready for some more? All right, the next thing is called the, I think I'm pronouncing this right, the folium of the Descartes. And it is x cubed plus y cubed equals 3xy.
This is another Rene Descartes thing.
What?
Is another thing from Rene Descartes.
I think it's Rene.
Yeah.
Unless there's another famous Descartes in mathematics. So we're going to find dy dx first. And B, we'll find the tangent line at 3 halves, 3 halves. And then C, we'll find where the tangent line, where is the tangent line, horizontal and quadrant line. And I have no idea what this looks like, so I'm going to go plot it. Just so you have an image of what it looks like. Oh. This is interesting. When we do the horizontal, at 0, 0, it's going to show that it's both horizontal and not horizontal, which is deep. Now it looks like we got another one somewhere up here. All right, so dy dx. Go. You guys know how to do implicit differentiation. Let's let you guys run and take a jab at it for a couple minutes, then we'll do it together. Just do part A for now, unless you're feeling really confident with your answer. So you need the answer to A for parts B and C. You all can't talk to each other. Like Jacob and Brianne do. No one else in the class like works with anyone else. Blows my fucking mind. I thought, was hoping with the group practice session, get you guys talking to each other.
So like,
So
okay, we can.
yeah.
So with my families, like, we would. But I did.
No, I have to explain.
Get only to this point because of the thing is, but because it's
What do you, when you do like a function with y, do you write it as, like for this one, it would be,
So the y cubed in this problem.
turns out to be 3y squared dy dx.
Yes.
Y again,
Not y again,
but just,
No, like
3y
the
squared dy dx.
3y squared.
So when you're taking the derivative of y cubed, treat it like it's an x, what you would do there, but then slap a dy dx on it.
okay. Yeah, you just don't need the second y after. Then you have to write the y.
That's what you should do. This 3xy is a product rule, so you're gonna have to do the product rule. Can we get that?
So
Can
I
we get close to that?
Well, so I got that, but I was trying for some reason to like get it even. For some reason, I said divide everything by 3.
Oh, well, we're gonna do that next. I just took the derivative for now. We can tell those threes to fuck off. Divide everything by 3. Definitely what I would do. I'm gonna have fun and get the y's on, or the dy dx's on the right today. So let's subtract everything with the dy dx over to the right. And move that y to the left using subtraction. You should get the same thing with that. After you factor out the dy dx. So dy dx equals x squared minus y over x minus y squared. If you did it and got y minus x squared over y squared minus x, that's also the same. That's just doing a -1 over -1 on it. Depending on which way you moved it, you would have gotten a different answer. Same thing. So we found dy dx, and that's a valid alternative. Where's the tangent line? Or find the tangent line, we need the slope there. So the slope there will be plugging in. That's my m. We're gonna plug in 3/2 for both x and y. And I'm gonna clean this up a little. I'm gonna get rid of the fractions by multiplying top and bottom by 4. That'll get me 9 minus 6 on top and 6 minus 9 on bottom, which looks like -1. 3 over -3. That's my slope. We wanted the line. So we will have, we're using our points up there. Y minus y1 is y minus 3/2 equals -1 times x minus 3/2. This one actually kind of cleans up kind of nice. Y equals -x plus 3/2 plus 3/2 is -x plus 3. All right, where's that tangent line horizontal in Q1? Part C, that happens when m equals 0. And that's our dy dx, so x squared minus y over x minus y squared. We don't want x minus y squared to equal 0. So x shouldn't equal y squared. That was when, remember the way the graph looked, it was like this. So that's recognizing like the vertical tangent line would have x equal to y squared. Actually, it kept going like that. So we're gonna set the top equal to 0. X squared minus y equals 0. So y equals x squared.
Thank you, excuse me.
And like in the last one, we're gonna plug this into the equation at the top. We get x cubed plus x to the 6th power equals 3x cubed. So I'll get them all on one side. X to the 6th power, I'll subtract 3x cubed over, and we're gonna end up with -2x cubed. And we can factor out an x cubed. So x cubed equals 0 or x cubed equals 2. And we get x equals 0 or cube root of 2. The x equals 0 here is actually satisfying that. So we should reject it. But we already saw that it does work there. And we don't really have the tools yet to show you how to take that further to show it. Because right now, if we plugged in 0, we would get 0/0, which is an indeterminate form. Right? If I did the x equals 0, that's indeterminate. And we saw how to deal with that with limit laws, but we don't want to deal with limit laws here. We will learn L'Hopital's later this chapter, and that will help us with indeterminate forms in derivatives. Much more friendly. But we'll look at the cube root of 2. We'll plug that into our y equals x squared. And we'll get the coordinate cube root of 2. If you square the x, you're going to get cube root of 4, which is 2 squared inside there. Two to the 1/3 squared equals 2 to the 2/3, or 4 to the 1/3. Boom. All right, let's take a 10-minute break. I got one more topic in implicit differentiation, but it's more to point it out, but I want to give you guys a break. Wanted to do it earlier, and that problem went a little bit longer than I thought. Jose said I missed a Y on the first row. I don't know what that means. What first row? Okay, so we have one more topic in implicit differentiation, and it's kind of a short one. We do have necessary conditions to do it. We make 2 assumptions. Assumption 1, y represents a function of x. That is defined implicitly. By the given equations. Or equation. And 2, the function defined implicitly is differentiable. If either of these is wrong, or incorrect, then we're going to get nonsense for an answer. For example, x squared plus y squared plus 1 equals 0. If we use implicit differentiation here, we get 2x plus 2y dy dx equals 0. And after we solve it over, solve for dy dx, we're going to get negative x over y. We're getting an answer here. You have a slope. What if I rewrite this, though, as just subtract 1 from both sides? What is that telling me? What is that giving me? A circle of radius negative 1. Nope, square root of negative 1. Circle with radius square root of negative 1. There's no real answer to that. Another way of looking at that is subtract the x squared over as well. And we have y squared equals negative 1 minus x squared. But negative 1, no matter what x is, x squared is positive, no matter what x is, and that means this is negative, which means negative 1 minus x squared is less than 0. There's no way for it to be equal to 0. It's less than 0, so we're saying y squared is less than 0, but there's no way to get something squared that's less than 0 without it being complex. So, like, this is nonsensical. So that's just the assumption we're making. Sometimes you don't have an easy way of checking that. All right, you guys ready for more? Give you a little bit longer to write these down. We'll start 3.2. We won't finish it today, but that was anticipated. You look at the syllabus, we're doing it today and Monday with 3.2. Or Tuesday? What day is it?
It's Tuesday.
It's Thursday, so don't Tuesday. Yeah, fucked you up already. I do not know why I struggle with what day of the week it is in the fucking morning. I don't know why.
Last night I was like getting ready for bed, and for some reason it felt like a Friday. I was like, everything's felt like a Wednesday, and then I went to bed. I was like,
On Tuesday, I thought it was Thursday.
I work nights at a hotel. So whenever I get off, it's like, what day of the week is it? Because I go in the previous, I previous one day, get out the next day, and then I have class, and then just screw me over.
Ain't it a bitch when you wake up and you're like, oh, good, it's Friday or Saturday or Sunday? And then
No, we-
you're fucking, you're like, I go back to sleep and why the fuck is the alarm going off? And you're like, you go to turn it off and like something clicks, hopefully. No, it's not, but I gotta get up.
The worst is when you take a nap, you wake up and you forget like where you're at, or what day it is.
Naps are like that happens with naps, but even better when when you wake up out of the nap and it's like sunset.
Oh, yeah.
Oh, yeah.
Because it feels like there's the light still coming through the window like it's sunrise. And you're like, holy shit, it's the next day. I gotta get up and get ready. Yeah, that's a bitch. All right. 3.2. Derivatives of logarithmic functions. So we're taking the derivative, we're going to start with the natural log of x. And to do this, we are going to switch to the limits. This is natural log of x plus h minus natural log of x over h. And since this takes up quite a bit of space, I'm going to go left to right and then down line. I'm going to put the 1 over h out front. And then I'm going to use the property of subtraction of natural logs that allows us to put this together as x plus h over x. And then I'm going to separate this. I'm going to do x over x, which is 1 plus h over x. And now it looks kind of ugly, so I'm going to make a b. I'm going to make a substitution. I use v in the lecture notes, so I'm going to use v here. I'm going to say b equals h over x. So that means h equals bx. I clear fractions. And this also tells me as h goes to 0, b is going to 0 also. That's going to allow me to switch this over. I'm going to use bx here now. Or b. I mean, as v goes to 0. And we've got 1 over h, which is 1 over bx times the natural log of 1 plus v. All right, so this is a limit in terms of v. I can actually pull out the 1 over x. This is not part of it. It's a constant with respect to v. Then we're gonna take that v 1/v and treat it as an exponent on what's inside. We're taking advantage of limit rules. Or not limit rules, natural log properties. A coefficient on a natural log can be an exponent of the inside. And now we're gonna move the limit inside the natural log. We saw this is something we could do back in limits. I think I got enough parentheses there. We saw this same thing with X. Previously. This equals E. It's one of the ways E is defined. So this ends up being 1/x natural log of E. But what is the natural log of E? It's just 1. So we get ddx of the natural log of x equals 1/x. How does this change if we're not using natural logs? Let's do log base b of x. Well, we can use it, the change of base formula to switch this where we do have natural log of x. There'll be natural log of x on top with natural log of b on bottom. And b is just a number, so natural log of b is just a number, which means 1/natural log of b can be factored out. And we already know that's 1/x. So ddx of log base b of x is 1/x natural log of b. That's our other version. You guys ready for more or some examples?
Those are constants, right? Those are,
Natural log of b is constant. What do you mean constants?
or not like constant, but like that's always gonna be that, like anytime we see.
Yes.
Okay.
These formulas you can take to the bank. If I'll cash it. There are some requirements that are already stuck in natural log, x has to be greater than 0. But that's a property of natural log. You can't plug in 0 or a negative number. All right, let's take a look at our first example. Y'all ready? Does anyone need this up longer? Let's do the derivative of natural log of x squared plus 4. I'm gonna write this, I'm gonna say u equals x squared plus 4. So this becomes the derivative of the natural log of u. And so we can see here u is a function of x, which means when I take the derivative, I get 1 over u, and then this is the implicit differentiation. I got to do du dx. But u was 1 over x squared, or u is x squared plus 4, so 1 over u is 1 over x plus 4. What is du dx?
So it's just 2x, no, just 2x, right?
Yeah, du dx is 2x. So we can write this as 2x over x squared plus 4. What's wrong with me? You don't like that?
No, I was doing,
Did you do the chain
I
rule?
did the chain.
We're gonna do the chain rule next.
Oh.
I was wondering if that's what you're doing. Another way to look at this is chain rule. So we got to hit the derivative of the outside, then the inside. So the derivative of the outside, the derivative of natural log is just throwing that shit on bottom. And then the derivative of the inside is 2x. And then now what we got right there? That's the chain rule approach. Sometimes the chain rule approach is really fucking messy and it's handy to do the u substitution, as you'll see on our very next example. Let's do d dx of the natural log of x squared cosine x over 1 square root of 1 plus x. Thank you. Yeah, you can take the chain rule here. There's a really good chance you're gonna fuck that up, because there's a lot of fucking parts to it. So what I'm gonna do is say u equals the inside. And this becomes ddx of ln of u, which is 1 over u du dx. And 1 over u is just flipping this bad boy over. So that gives us part of it. I still need the du dx. So we want du dx. This is a quotient rule. So high is x squared cosine x. And low is square root of 1 plus x. Or it might be easier to look at it as 1 plus x to the 1/2. Bless you. H prime is a product rule. We'll do the derivative of the first and get 2x cosine x. And then we'll do the derivative of the second. Derivative of x or cosine x is negative sine x. So I would write this as 2x cosine x minus x squared sine x. That'll be my H prime. And L prime is bring the power down, lower the power by 1, and then take the derivative of the inside. But that's just 1. So low prime is going to be 1 over 2 square root of 1 plus x. And remember, when we're doing the quotient rule, we got high prime low minus high low prime over low squared. That's what we're going to plug in here. That's my high prime. Times my low, and my low is square root of 1 plus x. And we have minus pi, which is x squared cosine x, times the derivative of low, which was 1 over 2 square root of 1 plus x. Oh, I barely squeezed that in, did I? Let's see this. All over low squared. Low squared is square root of 1 plus x squared. Gonna pause because we got a lot of cleanup here to do. But make sure everyone's on the same page. The cleanup's not actually too bad because we're going to distribute this numerator. And that's going to tell all those square roots that go fuck themselves. And there really is not a whole lot of things that are more satisfying than telling something to go fuck itself. Especially if they piss you off, and generally radicals piss me off. They're in my way, fucking up my math. Makes it difficult. So what I'm gonna do is I'm gonna take this bad boy and distribute it to this. And distribute to this. So I've got 1/x² cosine x left out front. When it hits this, it's gonna be a square. And that's times 1 plus x. And when it hits the second one, it's just gonna cancel out this denominator and we're just gonna have 1 minus 1/2 x² cosine x. And the bottom is 1 plus x. We're almost there.
Jump for the. Figure it out.
So this 1 plus x is times all of this. Let's break this into 2 fractions, separating it there. So I'm gonna have 1/x², well, let me do the top, 2x cosine x minus x² sine x times 1 plus x over x² cosine x 1 plus x. I'm just splitting it, shit will cancel out in a second. Minus 1/2, I can move the 2 to the bottom. Make this x² cosine x over 2 x² cosine x 1 plus x. Almost done.
Jones, where'd the 2x² come from on the second one? On the bottom.
The 2 comes from this 1/2. And the x² cosine x comes from this side here.
Okay.
Okay, so on the left one, the 1 plus x cancels. And if I separate this part into 2 fractions, I have 2x cosine x over x² cosine x. An x and a cosine x will cancel, and that's just going to be 2/x. So I'm breaking this one up into 2 parts right here. Now we're doing minus x² sine x over x² cosine x. X² cancel. What is sine x over cosine x? Tangent. So minus tangent x. Then I've got minus x² cosine x cancels that out right there. And we have 1/2 times 1 plus x. And that's where it ends. We're done there. Let's call that a wrap there. I think I can get the next problem done in 5 minutes, but I'm not confident, I'd rather just say, get back. Have a good weekend, I'll remind you I'm at the Mid Center on Saturdays from 8 to 2. Don't be a stranger. Jake and Brianna come out and study with me all the time. Looks like it comes out once in a while.
That'll be fun.